Good morning, ladies and gentlemen. My name is Baoping from China University of Petroleum. It's my honor to be here to introduce the progress in the research and the development of offshore oil and gas technology and equipment. My report will be divided into the following 4 parts. First, please allow me to introduce myself. I'm the Dean, the Professor of College of Mechanical and Electronic Engineering. Currently, I serve as the editor board member, subject editor, and associate editor of 3 SCI indexed journals. Let me introduce my university. It's located in the beautiful city Qingdao. China University of Petroleum is short for UPC. It's a national key university, one of the national double first-class universities, and one of the national Project 211 universities. UPC has its origin as the first higher education institute on petroleum in China and has gone through several name changes and moves. There are more than 19,000 undergraduate students, more than 11,000 postgraduate students, and more than 900 international students. At present, UPC has more than 3,000 faculty and staff, more than 1,000 professors and associate professors. We could be proud of that UPC ranks first in the quality of graduate in university with first-class disciplines, and UPC performs well in many academic rankings. A lot of resources are invited in scientific research. At UPC, there are 8 national research platforms. UPC's engineering ranked 46th rate globally. Our teachers and students have researched many research achievements since 2016. Students enjoy a vibrant, diverse, and safety life at the university. Our campus is a busy place with more than 100 student organizations. As the Deputy Director of National Engineering Research Center, I will introduce this institute. It's established by the National Development and Reform Commission in 2016. It's oriented to the major national strategic tasks and key projects for the development of offshore resources, dedicated to core equipment and key technology innovation. The main research area of National Engineering Research Center include innovation design, advanced manufacturing, intelligent detection, intelligent operation and maintenance, and safety areas of offshore oil and gas equipment. The following are the research team leaders. I will present their team's research progress later. I'm mainly engaged in the research of intelligent operation and maintenance technology. So let me show you the team's research progress in this field. Developing these resources is the key strategy for becoming a maritime engineering power. Subsea block prevention and Christmas tree, critical for oil and gas explorers, and dominated by American companies. Present a technical bottleneck in our country's oil and gas equipment sector. The absence of efficient solution for ensuring the high reliability design, efficient healthy management of subsea BOP and Christmas tree is a major obstacle to the advancement of oil and gas equipment. In view of the challenge faced by subsea BOP and subsea Christmas tree, such as poor operating reliability, low diagnosis accuracy, and high operating cost, 3 scientific issues are clarified. And research on design method, technology, healthy management method and carry out. 3 innovative outcomes are achieved. In the study of high reliability design method of subsea BOP system, there are many challenges and difficulties in front of us. The reliability of key mechanical components is unevenly distributed. The control system had poor swing performance and weak ability to withstand chemical failure. An original technology indicator of the integrity factor is proposed. Based on the indicator, an integrity design methodology is created to balance the working reliability, risk control, and use economy of key components. This methodology is used to guide the development of the machine system of subsea blowout preventers. A new concept of source shock probability is proposed. The cascading failure rules of control components are described, and the voting algorithm, arbitration logic, and seamless switching method are developed. Based on the technology, the control system of subsea BOP's development by a company of China, Rongsheng, which is certified by DNV and API. The expert group, composed of academics Shen Zhonghou and Su Yinao of China Academy of Engineering, believes that our research is a major breakthrough in our country's oil drilling and offshore engineering equipment. Now let's talk about our second outcome, non-performant and concurrent composed fault diagnosis. In the same way, we faced a number of challenges in conducting this research. Convenience, non-performant, and concurrent composed fault consist in the subsea BOP and the Christmas tree. The fault characteristics are strong composed with a noise signal, making it difficult to extract, separate, and diagnose. The state of illusion rules of transmit, intermittent, and permanent fault of subsea BOP are revealed with Markov, and the big data-driven online monitoring and fault diagnosis method is proposed. The accuracy of the subsea BOP fault diagnosis reached 98%. The mapping relationship between multi-point concurrent composed fault and multi-symptom pulse is discovered, and an intelligent fault diagnosis method for subsequent tree and integrity multi-source information is developed. Based on this method, several sets of subsea BOP and Christmas tree for diagnosis hardware and software have been developed, which are certified by BV and have been used in drilling platforms. The third outcome is fault prognosis and healthy management for subsea system. The healthy management method is lack of the deep integration of cyber and physics. This results in low fault prediction accuracy, long maintenance cycles, and high operation cost. And achieving the unity of information and units and physical system description of subsea BOP and Christmas tree is a difficult problem. To solve the above problem, the phenomenon of equipment dependency of degradation leading to sudden change in its IOR is discovered. Combining with dynamic update of conflict avoidance, real-time interaction, and consistent tracking of equipment, cyber physics is achieved. A reprediction method is created and a fault prediction software system is developed. The conditional-based maintenance method for subsea Christmas tree centered on availability is proposed, and a healthy management method of early diagnosis, fault prediction, maintenance decision-making is constructed. The conditional-based maintenance software system is used in the oil field in South China Sea. Let me show the engineering application of fault diagnosis of subsea BOP control system. We did lab testing. A fault diagnosis experiment is conducted in the offshore oil and gas equipment technology library of China University of Petroleum. The accuracy of diagnosis of subsea BOP hydraulic system fault, sensor fault, and electronic fault are all more than 90%. We did factory testing. The accuracy of 50 randomly set fault is 100%, and the BV company conducted a third-party witness on the entire process. Most important of all, our team went to the offshore plant to test the system. On-site testing is conducted on subsea BOP of offshore drilling platform in Haiyang Shiyou 981 and Nanhai number 10. Now, what I'm showing you is the intelligent operation and maintenance system of subsea production system. The on-site testing is conducted on subsea Christmas tree in Liuhua 41 oil field. The diagnosis accuracy of the minor and composed fault in subsea production system is 98.4% and 96.7% respectively. So next, I will introduce the in-deep profile control and water shut-off technology. The technology comes from Professor Dai's team. Professor Dai is a winner of National Science Fund for Outstanding Young Scholar, Changjiang Scholar, leading intelligence in 10,000 intelligent plane. Her team's research interests include oilfield chemistry and EOR, chemical water control technology for high water cut oil field. In the process of water flooding development in oil field, water train to break through along high permeability layer or fractures, resulting in higher water production and low oil production. To solve the above problems, Professor Dai proposed in-depth profile control in injection well and water shut-off in oil well. This approach can increase the sweeping efficiency, reduce the water cut, and improve the oil production without need to identify the water production location and move the tubing. The first outcome is dispersed particle gel for in-depth profile control, utilizing cruising links and dispersed technology. Dispersed particle gels with different particle size distribution is obtained by mechanicals shared and physical round specific bulk gel formed on the ground. A series of DPG produced that was suited for different resources have been developed. DPG demonstrates excellent injectivity, high prolonged capabilities, strong erosion resistance, and significant in-deep profiles control capability. The intelligent sky-mounted equipment for integrated production and injection have been developed, enabling on-site production of DPG produced, real-time matching with injection pressure, and intelligent injection. "27 oilfield service companies were licensed to produce the productions, and 32 industrial production lines have been established. The technology has been well used in 29 oil fields in China. The second outcome in water shut-off is oil wells. For different water immersion types, the following processes have been developed. Pressure, temperature, field match the sequence in-depth water shut-off. Chemical barrier for control bottom water ride advancement. Integrated nitrogen CO2, energetic drainage plugin for water control. Inventions include a series of plunging systems such as the gel-enhanced foam, and gel particles, meeting various resources conditions. Since 2015, 160 water shut-off operations have been fished, with 85% success rate. The next, I want to share deep water wellbore flow safety control technology with you. The technology was proposed by Professor Sun Baojiang. Professor Sun Baojiang is a Changjiang scholar of China University of Petroleum. His team's research interests include the theory and technology of deep water oil and gas drilling well control, deep water wellbore natural gas hydrate prevention technologies. Wellbore flow safety control is critically important in oil and gas drilling. Improper control can lead to a big accident. China's deep water and deep oil and gas resources are abundant, but the resources are characterized by 3 high, 1 low, and 1 narrow. Wellbore flow safety control faces the more serious challenges. To solve this problem, Professor Sun's team proposed 3 inventions, established the enterprise standard and regulation for well control, and proposed their application demonstrated and internationally. The first outcome is ICGLS 4-force flow deep water well control series. Clarified the influence of the hydrate formation on the rheological properties of the multi-phase flow. Discovered 2 new flow patterns in the wellbore, acid liquid and liquid. Revealed the evolution mechanism of all flow patterns in the deep water bore multi-phase flow, and established the scientific characterization method for the flow parameters, such as flow pattern transit criteria, volume fraction, and flow resistance. The proposed method improved the accuracy of the borehole pressure calculation from 67% to 92%. The second outcome is the key technology and application for hydrate prevention. Establish a multi-component hydrate fit equilibrium prediction model considering the influence of acid gases. They proposed a dynamic prediction method for hydrate form reason under different conditions. During deep water gas well testing, achieved real-time precise location and hydrate formation positions, laying the foundation for efficient hydrate prevention. They proposed the concept of the effective deposition rate of the hydrate particles, taking into account of the characteristic of multi-phase flow of gas, liquid, and solid and different flow patterns. They established a dynamic model for hydrate formation, transport, deposition, and blockage ability to deep water gas well testing, with the prediction accuracy exceed 92%, resolving the challenge of the accurately locating the hydrate, blocking risk during the deep water gas well testing. They selected the dual effect inhibitors. They proposed a method for hydrate blockage prevention, which involved the synergy between the installation test flow and the dual effect inhibitors, greatly reduced the risk of the hydrate blockage. Professor Sun's team developed a multi-point injection, real-time control, inhibitor injection system for deep water gas well. They created a real-time optimization and control software platform. The third outcome is technologies and equipment for drilling well control. Professor Sun's team developed a downhole transient response method device for temperature and pressure during drilling. They create a multi-information integration block warning software based on downhole and surface flow rates. Invented a multi-information integration early gas kick monitoring technology and equipment from downhole and surface. The team developed the leading deepwater well control software platform. They achieved the real-time optimization and control of the well control parameters, provided the brain for the well control equipment. They developed high-capacity Q well fluid regulation, mixture and supporting equipment. They create a serious dynamic drilling and Q well equipment system. The active wellbore pressure control technology has been applied in many wells and several deepwater oil and gas fields. So next, I want to share offshore engineering equipment design and manufacturing with you. The technology was proposed by Professor Xiao. Professor Xiao Wensheng is the director of the National Engineering Research Center. His team's research interests include theory and technical of offshore oil and gas equipment, permanent magnet direct drive drilling oil and gas equipment technology, and so on. China's offshore engineering equipment manufacturing industry has low market share, insufficient research, development, and several other problems. The common used three-phase motor need to install a reducer, which increases the failure rate and reduces the efficiency. There is an urgent need to develop a production equipment that can be adapted to today's complex well condition and follow the path of the green and low carbon development. In view of the current industrial pain point, the team, after 3 years, has designed and developed a set of oil subsea PMSM-based palm oil production equipment, which is suitable for the current situation of high side and wax heavy oil well with high efficiency, strong reliability, and low engineering consumption. The PMSM direct drive screw palm oil production system has been applied in many fields. After the verification, the system runs stably, which further verified the superiority of the equipment. With its advantage of the energy saving, high efficiency, and low failure rate, the equipment is unique in the exploitation of complex well conditions. The overall line-out design of FPSO topside model relies heavily on designers' experience, characterized by the substantial workload, long design cycles, and low automation. An AI-based algorithm for solving the center container layout problem is finally proposed, which efficiently improves the deck utilization, increases the overall stability, and meets the engineering requirement. The intelligent operation hybrid algorithm for solving a multi-pipe layout problem of a complex system is proposed, which efficiently reduces the pipe construction cost and the pressure loss. So MATLAB, Python, and SolidWorks are combined to develop an intelligent layout software of the Kyoto N999 FPSO. And the software can provide the reliability design support for designers. Ultra-deepwater pile hammer is the key equipment necessary for deepwater penetration pile installation. According to the impact characteristics, the force relationship between each component, its analysis, and the underwear impact system model is finally established. The vibration analysis and the vibration reduced technology research is also conducted by the team. The complete strike circle is simulated. the displacement, velocity, and acceleration cruise are obtained, and the performance parameters such as strike force and strike circles are obtained. The next, I want to share Razor Design Safety Assurance Technology. The technology was proposed by Professor Chen Guoming. Professor Chen is one of the national-level talent in the new century. His team's research interests include marine structure safety technology, oil and gas safety engineering information, and intelligent technologies. Razor subsea well handling the soul of the exploration and development of all deepwater oil and gas resources. Razor safety accidents occur frequently. It may include operational failure accident caused by the actual load and integrity failure accident caused by the long-term load. To address the challenge posed by the unclear composing mechanism, incomplete safety operation decision, different safety management in the drilling Razor subsea wellhead system, 3 scientific issues are identified, leading to the research in the theoretical method, operating safety, and structure integrity. 3 innovation outcomes achieved. The first outcome is a mechanical analysis methodology. The Razor subsea wellhead upper tensor model, lower assemblability loader model, inter-drilling fluent loader model, and actual hydrodynamic model are created. The composing dynamic model and intuitive solution algorithm of drilling platform, tensor, Razor, subsea wellhead, and shallow wellbore are pioneers. The composing dynamics experiment of Razor multi-structure is carried out, and the composing system dynamic solver and industrial software with independent intellectual probability rights are development. The resistance effect of Razor subsea wellhead response, the large deform and stress firmness, and the response bottling, the first promoting and the inhibiting effect of the Razor on platform drift movement, the inhibiting effect of the tensor on Razor lateral deformation, and the 5-stage response process under the internal wave are founded. A quick analysis method of safety operating window is developed, and a complete set of safety operation window of lower installation, connecting drilling, emergency disengaging, hanging recovery is established. Based on the multi-structure full composed model, the state inversion algorithm and operation safety control strategy of the Razor subsea wellhead system are proposed, and the real-time monitoring and early warning system of the Razor subsea wellhead is integrated. The safety operation strategy of flowing platform, Razor and subsea wellhead under internal wave and typhoon is proposed, and the world's first anti-typhoon Razor suspending device is developed. The suspend device has completed 2 engineering applications demonstrated in the South China Sea, and the emergency seas condition has increased from once in a year to once in 100 years. Based on the multi-structure fully composed model, a refined evolution method for Razor subsea wellhead vertigo is established, and the gene coding method is used to characterize the bonus blooding configuration of Razor system, and an intelligent optimization technology for Razor system configuration is proposed to reduce figure dynamics. The whole life cycle integrity evolution method of riser and subsea wellhead established considering the completing relationship of each failure mode. The resonance bedding fatigue test equipment, special test pails, and the device for the riser and subsea wellhead are successfully developed. A reliability update model for riser and subsea wellhead is established by integrating integrity assessment model, inspecting data, and maintenance information. Multi-level maintenance optimization technology for risers and subsea wellhead is created to minimize the operation, maintenance cost, and integrity management system is developed. The following are the application of the riser design and safety assurance technology. The research results have been widely applied to more than 15 wells in South China Sea. That's all. Thank you for listening.